Now let's discuss rational functions and asymptotes aside from the horizontal and vertical asymptotes that we've discussed before. We'll begin with slant asymptotes. And here's the definition for it. When you're given a rational function f where the power of p of x, in other words the numerator, is greater than or equal to the power of the denominator q of x, then you can rewrite our function capital F of x as capital Q of x plus r divided by our original denominator, lowercase q of x. And there will be an asymptote at y equals capital Q of x, where capital Q of x is the quotient of the division from p of x by q of x. In other words, we're going to get another polynomial coming out, and this r is the remainder over the original denominator. And this quotient or new polynomial that we're getting, that's going to be our asymptote. More often than not, it will probably be a slant asymptote or a line of some sort, but it could also be a higher degree polynomial, such as a quadratic. Let's look at some examples to see how this works. We're going to begin by performing the indicated division, meaning we're going to do x squared plus 6x plus 5 divided by x minus 1 to get our quotient q of x plus the remainder over x minus 1. And we'll use synthetic division. If we use synthetic division, what we're dividing by is 1. We have coefficients of 1, 6, and 5 in our original numerator. We bring down the first 1. 1 times 1 is 1. Add, we get 7. 1 times 7 is 7. Add, we get 12. So therefore, we can rewrite x squared plus 6x plus 5 divided by x minus 1 to be x plus 7 plus the remainder of 12 over x minus 1. So we're going to end up having a slant asymptote along the line x plus 7, and we'll see that on the next slide. So here's the graph. We have our vertical asymptote at x equals 1, because if we do factor the numerator, we'll get x plus 1 times x plus 5. There are no factors that cancel out, so x equals 1 will be a vertical asymptote. And then when we did the division, because x squared is a higher power than x to the first, that means we're going to have another type of asymptote besides a horizontal or vertical line. And in this case, because it's just 1 greater, it's going to be a slanted line. And that's found by doing the division that we did. We did it synthetically to find that q of x was x plus 7, and the remainder was 12. So we ended up getting x plus 7 plus 12 over x plus 1. This was our solution when we did the division. And you'll see that the graph of this function, it comes and it rides along x plus 7 and then shoots down as it approaches positive 1, and then it comes back up from the top, comes down, and then rides along that slant asymptote, increasing. Now let's try an example with a rational function that has a parabolic asymptote. It's going to follow the same steps that we did in the last example that had a slant asymptote. We're going to begin by performing the indicated division to determine what our new polynomial function, capital Q of x, and the remainder are. So our original function, capital F of x, is equal to x to the third plus 3x squared minus 2x minus 6. And we're dividing it by the binomial x plus 1. If we compare our leading exponents, we have x to the third and x to the first. If we divide them, we'll end up getting an x squared. That means that the x squared is our quadratic asymptote. Like, you can tell that it's going to be a quadratic asymptote. Now the exact equation of that quadratic asymptote we're going to find by doing division. You can either do long or synthetic. The work shown here is going to be through synthetic division. So our factor is -1, and our coefficients of the numerator are 1, 3, -2, and -6. We bring down the 1, do the multiplication, and we get -1. 3 minus 1 is 2. 2 times -1 is -2. -2 plus -2 is -4. -1 times -4 is +4, and if we add up -6 and 4, we get -2. That tells us that our quotient is going to be x squared plus 2x minus 4 minus the remainder of 2 over x plus 1. Now, you could also write the remainder as plus and then a -2 as the coefficient up here. Either of those would be acceptable, but in order to lessen the number of signs, we, instead of writing plus -2 over x plus 1, we just wrote it as minus 2 over x plus 1. And now let's look at the graph. So as shown in the graph, we have two asymptotes. The first one, or the giveaway, is the vertical asymptote at x equals -1. So that's this dotted line going straight up and down. And now when we did the synthetic division, or you could have done long division, you would end up getting the resulting quadratic and remainder. You would get x squared plus 2x minus 4. That's our parabolic asymptote. The quotient is in this case, and then minus the remainder 2 over x plus 1. So we graph that asymptote, x squared plus 2x minus 4, and we can see that the function rides along that quadratic asymptote or parabolic asymptote, and as it approaches -1, our vertical asymptote, it's going to shoot up towards infinity again. And then on the other side of our vertical asymptote, it's going to come from -infinity and work its way up, and then it's going to hug the parabolic asymptote again, this time on the outside of it.